Now let's look at a more complex example where we use a flowchart to design the algorithm for a processing program to draw an image that uses repetition. Imagine that we wanted to draw an image that looked like this. Let's first break this down into parts. Can you identify the part of the image where we are repeating instructions? That's right, it is a sequence of lines in the image. We could create a flowchart for the design of this image by decomposing the problem into its different parts. First, we want to create the canvas. Then we draw the first rectangle, then we draw the sequence of lines, and then we draw the final rectangle. How do we know if we have drawn enough lines? In this example, we want to draw 5 lines, so we can modify our expression to be something like, have we drawn 5 lines yet? If we wanted to write processing code to do this, we could write it like this. This will draw our image, but it's not the best way of writing this code. It certainly doesn't take advantage of the repetition in our algorithm, and does not reflect our flowchart. We can use a repeat statement in our code to make our code more efficient, and also much more readable. Processing code that uses a repeat statement to implement the above image would look like this. What is the difference in this code? The difference is that we have used a for loop statement to help us repeat the call to the line function the required amount of times. Let's explore this example in more detail to see what is happening here. Remember that we have introduced a for loop that can enable us to repeat a pattern in our program multiple times. However, as we saw earlier, a pattern is not necessarily simply doing exactly the same thing over and over again. As you can see in our image example, we repeatedly draw a line, but each line is slightly different. Each line is 20 pixels further across than the other. This represents the pattern that we need to write into our program. A for loop is great for implementing this kind of pattern, a pattern where you do almost the same thing again and again with a slight but consistent change. And this is where variables come in handy again. We can use a variable in our for loop to hold the value that is the basis for our pattern. In this case, that is the value that is used to represent the x-coordinate for the starting and ending points for our line. We can use a variable to hold that value and update that value each time we repeat the set of instructions. This is what we are doing in our for loop example above. Let's have another look at it and see whether we can understand what is happening. Recall that a for loop consists of the following template. The initialization section is where we can declare a variable that holds an initial value, in this case the x-coordinate for the first line. The test is where we write the expression that tells us whether we need to repeat the instructions. In this case, it is whether our x-coordinate is greater than 130 pixels, in which case we don't draw any more lines. And the last part, the update, changes the value of the variable declared in the initialization to get it ready for the next go through the loop. In this case, adding 10 pixels to the x-coordinate. Let's watch this execute line by line and see what happens. Okay, now that we have seen a few examples of repetition and the use of the for loop in processing, let's see how well you can match a pattern in an image to the code that generated it.